Section 9.6 starts off with our concept of understanding when we multiply two things and we get 0 as an answer, that we know that one of those two things has to be 0, or both of them. So we know that in this situation, x times y, if that equals 0, we know one of two things: x equals 0 or y equals 0, or both of them equal 0. So we're going to use that concept to help us figure out, actually solve some quadratics this way, because graphing to solve them doesn't always work out the best, as we have discovered. And we can also run into some decimals and fractions and things like that. So on the last section, we would take something like this and we would graph it and try to figure out where the parabola or quadratic would cross the x-axis. And we found out that that could be in two places, it could be in one place, or maybe it didn't cross the x-axis at all. But what we're going to do today is we're going to look, instead of graphing, we're going to actually factor. And it's a quicker way to get your zeros or figure out where exactly it's going to cross, if it does at all. Or, like I said before, maybe it only crosses in one spot. Your vertex may be on that x-axis. So anyway, what we're going to do is take the x squared plus 2x part, and we're going to factor that. And not much we can do with that, except for we can take out x out of both of them, and we would be left with x plus 2 on the inside. So going back to our concept here of xy equals 0, remember we knew that x had to be 0 or y had to be 0. And our two factors there were x and y. Our two factors here are x and x plus 2. So what I can do is set each factor equal to 0. Sorry about my loud bell. So we could say x equals 0, and there's nothing to solve here. That's just one of our possibilities. And if x is 0, we could see that 0 times x plus 2, or I guess if x is 0, it would be 0 times 0 plus 2. Doesn't matter what we get in here, because 0 times anything is just going to come out to 0. So that is one of our solutions. And what we know then is that our graph, our quadratic, crosses at x equals 0, or the origin. All right, and secondly then we'll take the second part, our second factor, x plus 2, and we'll set that equal to 0. And it just requires to solve. It's pretty obvious that in order to make this 0, x would have to be negative 2. So if we were to graph our parabola, I know that on my x and y, or x intercepts are going to be at x equals 0 and x equals negative 2 and 0. Okay, so we found that out, and we just solved it without having to graph. And that's what we're going to do the rest of the way. This is actually one that we looked at earlier, and again, we can factor this. So one thing you can do, since we're in equation form, if this is negative and you don't want it to be, you can multiply both sides by negative 1. And we can do that since we're in equation form, meaning there's an equal sign. So remember, multiplying everything by negative 1 changes all of your signs. So really what we have here is 0 equals x squared minus 12x plus 36. And what we're going to look for here is two numbers. Since this is 1, that makes this a lot easier. We can just look for two numbers that multiply to 36 but add to negative 12, which is going to be negative 6 and negative 6. And here we can see there's only going to be one solution, x equals 6. That tells me that my vertex is at 6, 0. So 1, 2, 3, 4, 5, 6. And I won't graph the whole thing, but initially we had a negative x squared value, so it's going to go down like that, and your vertex is right on the x-axis. So only solution here, or the only place it crosses, is x equals 6. All right, and this is the new thing that you hadn't seen yet. This is called the difference of two squares. All right, and basically how you can think of this is there's no middle term. It is x squared plus 0 times x minus 49. And we can play that game again, since this has has no, a is 1, that makes this a lot easier, so we can pretty much ignore it. We're looking for two numbers that multiply to negative 49 but add to 0. So they're going to have to be opposites. So minus 7 and plus 7. And if this equals 0, I know here x could equal 7, or here x could equal negative 7. So those would be my two answers. But really, when you have the difference of two squares, what you can do is, for instance, let's say we had, let's do a different one here. Something that looked a little more funky, like 9x squared minus 16. We still have two squares, perfect squares. 9x squared can be broken down into 3x and 3x. 16 can be broken down into 4 and 4. We know one of them has to be negative. So this factors into 3x minus 4 and 3x plus 4. So this is how these factor every single time. So that's the difference of two squares. And if it's set equal to 0, then we just take each one. So for instance, 3x minus 4, and we set that equal to 0 and solve. So plus 4, and then 3x equals 4, and we divide by 3. So 4/3, and that's just one of our zeros. The other one we would also have to solve, but in this case that would be negative 4/3 would be our other answer if we solve that. So you can see that graphing this would not be very fun because the zeros, or your x-intercepts, happen at fraction spots, and that would not be fun to find by graphing. That's where the quadratic formula, or the finding the solution via factoring, is a lot better. So anyway, my main point here is that when you have the difference of two squares, you're subtracting two perfect squares. It can always break down into its two square roots, minus and plus each other. Okay, and if you're wanting to discover anything more with that, let me know. But basically what happens there is your insides and your outsides cancel, which is what you want to happen because there is no middle term. Okay, so negative 12x plus 12x cancels there. All right, and then one last example, and I apologize, this video is going a little longer than I wanted it to. Here you can go the guess and check route. We have a trinomial. We know that it's going to have to be 3x and something times x and something, and you can guess and check your factorization. Or you can go the direct route, which means we're going to take 3 times 12, which is 36, and we're going to break that down into two factors that add a negative 13. That happens to be negative 4 and negative 4. So we rewrite this as 3x squared minus 9x minus 4x plus 12, and we group these. And out of these, we take 3x out, and we're left with x minus 3. Out of this, we'll take negative 4 out, and we're left with x minus 3. So our answer, or not our answer yet, but our factorization will be 3x minus 4 times x minus 3. Now remember, this is set equal to 0, so we do have to solve both of them. The easy one is the x minus 3. I know that here x could be 3 to make this 0, because if that's 0, 0 times the other factor will make everything 0. And then I just got to solve this one. 3x minus 4 equals 0. So add 4, and we divide by 3. So 4/3 would be our other answer. Okay? So that's how we use factoring to figure out the solutions to, or the x-intercepts for those quadratic graphs. So again, I apologize for the length of this one, but there was more that I wanted to cover than I realized. So that is it for 9-6.